Second application of Gauss's law is infinite line charge. So we have to find the flux density due to this infinite line charge. It's having charge density is rho L coulomb per meter and it's having length is L. So in this case, so in order to find the flux density at a point rho meter from this charge density, linear charge density. So this is rho meter. We have to find flux density at this point. So in order to find the flux density at this point, we have to consider a closed surface as Gaussian surface. Here we can assume a cylindrical surface as the Gaussian surface. Okay, so this cylindrical surface we can assume as a Gaussian surface. Okay, so we have to find flux density at this point. This is point P. This flux density D we have to find at this point P, which is at a distance rho meter from this linear charge density or linear charge. Now we apply the Gauss's law here. We know that according to Gauss's law, Q will be equal to closed integral D dot ds. Here the normal component of the flux density along this rho direction is d rho. So d will be equal to, we can write it as d rho a rho. Now we already know that from the linear charge density, we know that rho L will be equal to delta Q divided by delta L. And here we have the total length is L. So we can write the total charge Q will be equal to, along the whole line will be equal to, Q will be equal to rho L into L. Total charge along this whole line. So total length is L is given. So total charge will be equal to, Q will be equal to rho L into L. So this we can keep it as equation number 2 and this equation we can keep it as equation number 1. Now we substitute equation 2 in equation 1. Substitute equation 2 in equation 1. So what we get? Rho L into L will be equal to this closed integral d dot ds. But we know that this the normal component of the flux density is d rho integral ds. Now what is the total area of this cylinder? Here we assumed as cylinder surface is the Gaussian surface. So what is the total surface area of the cylinder? Here length is L and its radius is rho, which is same as the distance from the linear charge. So the rho is the radius and total length is L. So what is the total area of the cylinder? We can write it as 2 pi into radius rho into length L. Now we know that this is, which is equal to rho L into L. Now this L and L cancel on both sides. What we have to find? We have to find the flux density d rho, that is equal to this rho L by 2 pi rho. Again this can be written as d will be equal to rho L by 2 pi rho a rho. So this is the flux density due to linear charge. Rho L is the charge density by 2 pi rho. Rho is the distance from the charge density. D will be equal to rho L by 2 pi rho a rho.